Okay, this looks remarkably like the last problem, but it's not exactly the same. So what I'm going to do over here is like a U substitution. And let me write that down for you. So I'm going to say U equals sine squared x. So du would equal 2 sine x. I'm using the chain rule. And then cosine x dx. All right. Let's see if that helps at all. And looking at it, let's say I did that right. Well, I can write this down maybe a little differently, because 2 sine x cosine x is just simply sine of 2x. Well, that's getting remarkably more like the other one now, except it's a double angle formula. So let me write that down. And so I'm going to go from, let's see, let's just do the indefinite one first. I gotta be careful with this too, don't I? It looks like I'm gonna do integration by parts. Let me erase this over here. And let me write that down now. So I'm not, a U substitution doesn't seem like it's gonna help out at all. Let's try integration by parts. All right, so dv would equal 1 over x dx. All right. I'm sorry, 1 over x squared. So let's put v down. I want to point out this is x to the minus 2 dx. So it's going to be, let's see, add 1 to the exponent, so it's a minus 1. So minus 1 over x. All right, plus some constant. We'll do that later. Let's see if this is going to work out for us. So this is going to be equal to, and I got to do, let's see, it's going to be sine squared. I'm doing the uv now. It's going to be minus x here. The limits of integration, I should be using limits, but right now I don't know, I've been doing so many of these things, I'm starting to get tired of that. We'll talk about that later, by the way. And then minus, let's see, v, so plus 1 over x. And then the du, which is sine 2x dx. All right, let's not worry too much about what we're seeing over here, but I think I should do one thing at a time. All right, I want to do this over here, and I realize that there's really two things to consider over here. So really what I need to consider is, I need to consider the limit. I'm going to put a goes towards infinity of, this is going to be minus, I'll put the minus on the outside. It's going to be sine squared x over x. And certainly as you go towards infinity, this of course can go towards 0. So this is easy. This goes towards 0. Now the other one a little more complicated, isn't it? So let's put this one over here, and I'll put this 0 to infinity, sine of 2x dx over x. I got to evaluate that. It looks remarkably like the last problem. Let me erase this business over here. I'm kind of done looking at that. And I'm going to do a substitution now. I'm going to say u equals 2x, and du would be 2 dx. So I'm ready to put that down. It's going to be equal to, I'll put this over here. Let's see, if x is 0, u would be 0. And then you get twice an infinity, which is an infinity. You can get sine of u. And on bottom, what do you get? Well, what's x going to be? It's going to be u over 2 times 2 dx. I made a mistake there. So the dx is going to be 1/2 of the du. All right, it looks complicated. I got to really make sure you know what I want to do. I want to simplify that integrand. And so like u over 2, I get this over here, and then times 1/2. Well, these cancel off. So what are we left off with? We're left off with 0 to infinity, sine u over u du. Well, it's remarkable. We just did that one, and what do we find out? It's just 1/2 of a pi, so pi over 2. All right, kind of remarkable. So what I want to do is just, look at this over here. I realize I did a lot of work over here. I hope it's similar work, similar enough that we know what we're doing. And yeah, we got it. So we're doing okay. Thank you.